Okay, so we're starting with grains. Not starting, we're finishing with grains, I suppose. So we're going to create a new project. The name will be module, whatever you like, but this is module 1, week 6, in 2D. Okay, accept, and then save the hip. Very important, go to job, and then let's call it module 1 week 6 dot grains dot version 1 hip. Great. Okay, so now we need to find that project and bring in our files, our FBX. So here's the project, just drag it in, and then I've got the FBX here, so I'll leave that in. Do we have an FBX folder? We don't. We could just leave it in Geo and drag that zombie death in there. Okay, and then we can go to File, Import Filmbox FBX, and then go ahead and find that. So I saved it into Geo, zombie death, accept, import. There we have it. Spacebar and F, and we can see our lovely zombie. Okay, so first of all, he's too big, so I'm going to press P here and pointer 1, spacebar and F, and then we can see, roughly a bit under 2 meters, which is about right. And then I'm going to create a geometry node and call this grain. And we're going to object merge in just the geometry. We don't need the rig or anything like that. So go ahead in here and find this zombie geo, Control C on that, and then grain, grab an object merge, and you can just paste that in there. And we should see him now into this object. There we go. So that will take account of the transform there. Okay, so there we go. We've got our zombie, and he kind of falls over. You can see the animation is just about 70 or so frames. So we'll change our timeline to reflect that, just to find the end. Yeah, he's still moving for 70 frames, so I don't know if we'll sim it that long, but we'll take a look at that. So yeah, grains. Let's make a really quick simulation just to start out with a quick understanding of grains. So I'm first of all just going to get rid of the animation, drop a time shift, right click, delete channels, and then that will just freeze it onto the first frame there. Okay, and then so for vellum grains we need to use the vellum grain, which I can't see. Let's oops, don't want that. Let's just tab grain, vellum configure grain. There we go, and then just plug that in. And by default, it's not doing anything. So we just need to check this, create points from volume. So that will create a volume and fill it with points. Doesn't look great. Let's drop the grain size, 0.01. So you can see here we're having problems because of the geometry is it's not watertight, right? It has holes, but that's the the design. But things like this, you can see there we've got 2 separate pieces. This hand is a separate piece to the sleeve, and there's a hole that is not watertight, right? So easy way to fix that is drop a polyfill there. Okay, and you can see we get an error message. So if we just change that to single polygon, we will get n-gons, but it doesn't matter because we're not going to be rendering this geometry or doing anything with it. So we'll get that will fill the it will put a cap on those holes, and hopefully that will give us grains like that. Okay, so you can see all this this is not really doing much here. It's just it's the same as a points from volume, I think. So you could do that as well. It's the same thing. It looks different because here we're dropping this sprite material onto each point. So it looks like, you know, they're being lit, but it's just it's like an image of a sphere being copied onto each point. You can tell, you know, that the lighting is the same on all of them. So, you know, it's just you don't really need it. You can, well, there you go, you can turn it off there and they will be pretty much the same. So yeah, we're getting this grain size, which is the diameter, I think. If we go into the geometry spreadsheet, you can see oh, sorry, yeah. The P scale is the radius, and then the grain size will be the diameter, you know, all the way across. So P scale will be half of that. Mass is just set the same on all of them. It doesn't really matter unless you have different amounts of mass. And then we could just get this thing is grain. So that's just an attribute for the solver. So the solver knows that is to deal with these points as if they're grain, because, you know, it will go into a vellum solver, which, you know, it could be cloth or something else. And that's it, you know. So you don't really have to use this node. You know, it could be that your input, you're starting out with points from some source, I don't know, and then you could plug it into this actually, or you could just set these attributes up yourself. You don't have to use this this node. So, and then we can obviously use the vellum solver, just quick and simple. Plug that in like that. We don't need that or that. Oh, it requires the constraint geometry. It doesn't really, because we don't have any constraints set up here. We could, but we don't need to. Let's turn on the sprite material just for fun, and turn on the ground position, and turn on real time, and press play. And we'll see we get that. So, you know, you might wonder what's the difference between this and a particle simulation. The main difference is you can see that the grains, they shouldn't occupy the same space. So, you know, they know that they hold a P scale and a size, a diameter, and they shouldn't overlap or kind of interpenetrate each other. Okay, so that means they can pile up like this, and they can also look at each other, so they can stick to each other as well. Thing is, we don't have the options for that. We still don't know on the vellum solver here. We could just quickly, just to show you, it's not too important, it's just for demonstration. You can right click, go to allow editing of content. You can see that padlock's unlocked. Now I can go inside and see how they've built this HDA. Go into the .NET, go into the vellum solver, go into advanced, and then in grain collisions, there we go. We've got the the important parameters for grains there, and so these are kind of interesting: attraction weights and repulsion. So they tell the grains to try to stick together or try to push apart, which is pretty cool. Let's turn this to 1, and then hopefully we'll see some clumping there. You can see it's kind of working. The thing is with grains is that you generally have to start out with at least, I think in the documents it says at least 5 or 4 sub-steps before you get anything kind of usable. So straight away there, you know, we're getting something, we're starting to get these nice kind of clusters, clumps holding together. The problem is with grains, you're often fighting against this kind of thing where we're basically exploding, you know, they're bouncing all over the place. And the answer to that, unfortunately, is just sub-steps. So you can see it will run much slower, but we should get something much more stable. So, you know, that kind of effect there is not really, don't go looking for, you know, bounce and stuff like that. It's because it needs more sub-steps. So we still got 1 or 2 bouncing, which is okay. It's not a big problem, but the majority is sticking together, and we get this nice kind of splat, okay, which is kind of cool. Okay, so that's your, you know, basic grain setup, but, you know, obviously we're going to be doing something a bit more advanced than that.